Hi, my name is Rafael. Welcome to my channel, where we learn more about computer graphics each week. Today, we will create a grid, which is a bunch of squares or rectangles stacked together. Grids have many uses in computer graphics. They can be used for drawing, debugging textures, and simulating effects with the purling algorithm. When we talk about grids, probably the first thing that you think of is this checkerboard pattern. So let's start with it, shall we? The checkerboard pattern is a simple pattern made of black and white squares. And to create it, as well as any grid pattern, we must use modular arithmetic. Modular arithmetic may sound like a fancy name. Still, it is really just a way to introduce repetition by using division. We all learn that the remainder of 5 divided by 3 is 2. And there are 3 possible reminders for 3, 0, 1, and 2. However, we may have never learned that any function can become periodic by using the reminders of a division, and any image which may be seen as a 2D function as well. Okay, so let's get back to the checkerboard pattern. Since we only need 2 colors for the checkerboard pattern, we only need 2 reminders, 0 and 1, or to classify numbers as odd or even. So let's implement this, okay? I am using the site ShaderToy for this video, which uses GLSL. Still, the following code can be done in any language of your choice. We start with an image, in my case of 720 by 405 pixels. Every image is a matrix, as you know, in which the coordinates x and y store the color of a pixel, a 3-valued number that belongs to the RGB system, usually. Let's paint the initial image as blue. We can apply modular arithmetic already at this stage, but we would create 2 colored pixels that are too small to see, or to identify the colors really. In fact, we would make a Bayer pattern, an optical illusion. But how would it go? We only need to divide the x-coordinate by 2 using the function mod, which will return its reminder, 0 or 1. When mod x2 is 0, we will paint the checkerboard blue. Whenever mod x2 is 1, we will paint the pixel yellow, the complementary color of blue, because blue plus yellow is equal to white in addition color system. This will create a stripe, a type of pattern, but it's not what we want. To generate the checkerboard, we need to divide the y-coordinate by 2 and invert the colors using 1 minus color whenever the mod y2 equals 1. You may be wondering, why is the image gray when we are using blue and yellow? And the reason for that is that we have found the Bayer pattern, an optical illusion, as I said before. If we increase the size of the squares, we will see the blue and yellow squares, as we should. To do this, we divide this position x and y by the total pixels in the width and height. We will obtain a number between 0 and 1 in this manner. In my case, x should be divided by 720 and y should be divided by 405, which is the width and height of your image. Then we create a variable called anyTiles, the number of tiles we would like our grid to have in each dimension. Let's assign the number 10 for the initial value, which will create a grid with 100 rectangles, since we are not worried about aspect ratio at the moment. To create squares, however, we need only to divide x and y by 720 or 405 pixels. And as a sanity check, if you divide x and y by 720 and use 720 tiles, we should again find the Bayer pattern, a grayish color. Now let's be a little bolder. What if you wanted a checkboard with 5 colors instead of only 2? We still use modular arithmetic. However, instead of using 2 as our divisor, we should use 5 to obtain 0, 1, 2, 3, or 4 as a reminder. Since we have 5 values, it is best to use a switch for x and create a variable key to store the reminder. Since we can cast this value to a boolean, which only accepts 2 values, we will need to use an int this time, which is an integer type. Again, as a sanity check, we can create stripes to see if our algorithm is still working. But to create a grid, we need to consider y. And if we use it as is, it will create 5 new colors, which is not what we want. To solve this, we use a switch again, but change the order of colors when the reminder is 1, dividing y by 2. This doesn't change. In such a manner, even lines will have 5 colors, while odd lines will have another pattern of the same 5 colors. And that's it, we are done. For those who are more adventurous, I have created a third algorithm that uses textures, shadows, and the HSV system. I will not detail it here since it involves many concepts that I have not yet explained, but it should stimulate some of you to learn more. As an exercise, I propose that you try to create a shape inside the squares or rectangles of your grid. Do you remember the grid that Blender uses? I have shown it at the beginning of this lesson. Some of them have numbers or letters that also help to debug 3D models. Try and insert your own shapes in a grid. It will help you in the future. That concludes our first lesson. I hope that you have learned something today. Feel free to ask questions in the comments or send me an email. I will get back to you as soon as I can. Next week, we will meet again to learn more about computer graphics. See you then!